This video is the answer key for number 2 of the 8.2 warm-up. So for number 2, it tells you the graph of the first derivative of a function is shown. So paying attention that this is the graph of a derivative, and it says use it to answer the questions and explain your answers. I'm not going to be putting down my full explanations. I can just do abbreviations, but remember on the AP test they're going to be looking for full sentences, and don't use abbreviations or notes or symbols to do your explaining. So for part A, it says on what intervals is f increasing? So they're wondering about the original function f. So based off its derivative, how do we know if a function is increasing? Well, you have to remember that when a function is increasing, it has positive slope. So what we're going to look for in the graph are all the areas or the intervals where our derivative is positive or above the x-axis. So the interval from 2 to 4, my function would be increasing because that's where my derivative is positive. And then if I follow more of the graph at 6 and then to 9. And so I'm not going to write it, but you should. It says on what intervals is f increasing? I would write f is increasing on the intervals 2 to 4 and 6 to 9 because that is where f prime is positive. For part B, it says at what value of x does f have a local max or a local min? So remember, a local maximum is when your function is changing from increasing to decreasing. Well, that's the same thing as where your derivative would change from positive to negative. So I want to look at the graph of my derivative and see where it crosses the x-axis from being on the positive side to the negative side. So f has a local max at x equals 4, and I didn't mean to do parentheses. So f has a local max at x equals 4, and then you would say because that's where f prime changes from positive to negative. And then a local minimum is when your function is going from decreasing to increasing, or when your derivative is going from negative to positive. And so looking at the graph here, there's actually going to be a couple points. F has local minimums at x equals 2 and x equals 6, because that is where f prime changes from negative to positive. For part C, it says on what intervals is f concave up or concave down? Well, remember, concave up is when the second derivative is positive, and concave down is when the second derivative is negative. Well, when you're given the graph of f prime, you want to look at where does it have positive slopes and negative slopes. So concave up, or f is concave up on the intervals, and so I want to look where f prime has positive slopes. That would be from 1 to 3, and then from 5 to 7, and then from 8 to 9, because that's where f prime is increasing. And then f is concave down on the intervals when f prime is decreasing, because that's where f double prime is negative. So it's decreasing, f prime is decreasing from 0 to 1, and then 3 to 5, and then 7 to 8. And then lastly, it says, what are the x-coordinates of the inflection points of f? And so this kind of goes with your concavity. You have to remember that f has a point of inflection when concavity changes. And so the x-coordinates of inflection points, looking up here, since my concavity changed at 1, so it went from concave down to concave up, x equals 1, and then 3, because that's where f prime changes from increasing to decreasing, and then 5, because that's where f prime changes from decreasing to increasing, or your concavity changed, and then at 7, and at 8. And those are the x-coordinates of f.